How about this? Let's begin this video by going over properties of logarithms with the quickest log that we could actually write out. The quickest log we could actually write out would be log base e, because we call that a natural log. We call that ln. So let's demonstrate the product property. And product means what? Multiply. So if I have ln of x times y, then that would expanded would be ln of x plus ln of y. Let's look at quotient property. Quotient property. If I had ln, what does quotient mean? Divide. So if I had ln of x divided by y, then you would be able to expand it to ln of x minus ln of y. Okay? And last but not least would be the power property. Power. Okay, that's where you have something like ln of x to the y power. Okay? And we could expand that to become y times ln of x. Okay, why do we call product property? Because there's multiplication. And when we expand it, that multiplication becomes an addition problem, and this single ln splits into two ln's. The quotient property is quotient property because of the division, and what we do is split it. We take the single ln and split it into two, and it's going to be the top one, ln of x minus ln of y. And the power property is where you have a power, and that power goes down to the front and becomes multiplication. Now, all these properties could be and should be used forwards and backwards. We should know how to expand it and how to condense. Let's start with this warm-up activity. Please copy down this class opener, and let's fill in the blanks accordingly. So talk to a partner, and in a couple of moments, I will ask you guys to tell me what belongs in this blank spot, what belongs in this blank spot, and so on and so on. What would we fill in right here?
Log BS.
Log BS. That's a bunch of, okay, no. And that's a good example of why we should be able to say this correctly, right? Whenever we say log and you want to talk about this little value down here, you have to use the word base right before it, right? So log base b of, you have to use the word of before saying this, right? Of s. So yeah, log base b of s. Okay, so yeah, it is true. Log base b of r plus log base b of s equals log base b of r times s. That's a product property. How about the quotient property? Let's call on somebody. Natural log, so ln parenthesis p over q. That's what you said, right? That's perfect. That's quotient property. All right. And now for number 3, I do want you to recognize that there's a blank spot right here and down here. Okay? So let's call on somebody at random. Think about that last one, Lexi. This one right here is a what?
Is P.
P, okay. And then down here?
That one is C.
Absolutely. Cool. So again, the power property, it's just when you have some type of value that you're multiplying by right here, you could move it up to become a power on that value. Anyway, we need to know these properties forward, backwards. We need to be able to expand and condense. More importantly, condense. When we're solving logarithmic equations, it's good to be able to condense them, but it is good practice to expand. So let's start with that practice. Let's expand these four logarithms. Please copy these down. Please work them out. Show your work with a partner or help each other. But we're going to go through them in a couple minutes, so I'm going to pause it. Ladies and gentlemen, we need to have the 3 properties memorized. And if you know product property, quotient property, power property, all you got to do is think about number 4. What property are you going to use? Product. Why? Because there's 5x. That means 5 times x. You're going to use a product property. What property are you going to use on number 5? Quotient. What property are you going to use on number 6? Power. See, it's easy, right? So just apply those properties to make these longer. They're already condensed, so we're going to expand them. Now, number 7, that one's 2 properties that you have to apply, and it is important that you apply it in the right order. I'll get to that in a little bit. Does anybody have an answer for number 4? Rihanna, what's up?
I got log base 3 of 5.
Log base 3 of 5. Perfect. Log base 3 of x. This is expanding. Why expanding? It's small right here. Now it's bigger. Okay, it's expanded. We took that one single log base 3 and we expanded it. There's 2 log base 3s as an addition problem. Let's call on somebody for number 5. Francisco has log.
Base x or just x?
Let's ask this. What base is right here? 10. So you could say log base 10, or you could just say common log, whatever you want.
So log base 10.
Log base 10 of x, okay.
Log base 10.
Minus log base 10 of 4. Now, even though I'm saying base 10, I'm not writing base 10 because the common log, that means that you don't have to actually write the 10. Whenever there's no base indicated, you automatically know it's base 10. So yeah, that's the answer right there, expanding quotient property. And let's call on Edgar. Edgar, what do you say on number 6? What property are we going to use?
Power.
Power, that's right. We have this power of 7. What do I do with that power of 7?
It goes front.
It goes to the front. So you're going to have what? 7 times log
2
base 2 of x. And that's it. Now for the fun one. Let me move these out of the way here. If I want to expand number 7, how about this? Before we show this one, what if I told you simplify 2x to the 0 power? Since we already know that anything to the 0 power equals 1, what's this answer going to be?
2x to the 1.
It's going to be 2, right? Because the only thing that has the power of 0 is x, right? So x to the 0 is 1. You really have 2 times 1, and that equals 2, right? So why did I do that simple exponent problem? Because right here, you need to understand that the 3 belongs to the x, not to the 2. It belongs to the x. So if you're thinking power property and you move this to the front and then expand, that 3 is going to end up with the ln of 2, which is incorrect. Does that make sense? So it's important that we do the product property first to expand it. So if I use the product property, I'm going to put ln of 2 plus ln of x to the third. And then I use the power property, that 3 is going to come out to the front. So I have ln of 2 plus 3 ln of x. So as you can see, if you would have done the power property first, that 3 would be out here in the front, which would be a mistake, because the 3 does not belong to the 2, it belongs to the x. So that's why we do the product property first, split it with the plus sign in the middle. Thank you. And then we bring down that power of 3 to the front. Let's move on to condensing, which is a more important skill, because when we solve logarithmic equations, we condense. Check it out. 8, 9, and 10. Copy those down, please. We're going to be condensing using different properties. So you need to decide what property you're going to use. And on number 8, we have log base 7 of 8. Do we have 8 times something? No, so we're not using the product property. Do we have 8 divided by something right here? No, so we're not using the quotient property. What do we have here? We have log base 7 of 8 and something that's being multiplied out in the front. That's the power property, right? When you have something times a log, you could take that something and put it where? Up on top of the 8 or whatever value you're taking the log of. So in this case, we have log base 7 of 8 to the 2/3 power. Now that brings up some previous knowledge that we should have. When you have a rational exponent, an exponent that's a fraction like 2/3, the numerator is the power, the denominator is the root. So you really have the third root of 8. What is the third root of 8? 2. And then you have the power of 2. So 2 to the power of 2 ends up being 4. Or you could have done it the other way around and said 8, the power is 2. What's 8 to the power of 2? 64. And then the third root of 64 is still the same answer, 4. Does that make sense? So, or how about the easiest way of doing it? Getting your calculator and typing 8 to the 2/3 power, and it'll give you the answer 4. So your answer, your final condensed answer should be log base 7 of 4. Now it didn't say simplify it, it just said condense it. Like if I would have said, give me a approximation to 4 decimal places, then yeah, you could actually type this in the calculator and get 4 decimal places out and get an actual approximation. But do we understand how we applied the power property here? Okay, what property are we going to be applying on number 9? Power and product. All right, so let's begin with the power. This 4, we know it's with the x, so I need to move it up here and it's going to be a power on the x. If I would have condensed first by doing the product, then I'd have 5x and then the 4, it might end up on the 5, so it's better to keep that 4 on the x itself. Question?
And for the product.
So let's move this 4 to become the power of x. Put it right there. You could scratch it out now because it's now up there. And then let's condense it with the product property by putting this log base 2 and that log base 2 together as one single log base 2. But of what? Of this times this. So what's x to the 4th times 5? It's exactly that, but let's put it in order, 5x to the 4th. So there's your condensed answer on number 9. Log base 2 of 5x to the 4th. Now number 10 is pretty fun. Let's check out number 10. Let me get this out of the way. Let me move number 9 up here. Any ideas on condensing number 10? What should we do? What could we do? The power on which one? On both of them? Okay, so yeah, we could call this a -1 if you want to. So let me put a -1 right there, times log base 3. So I could take this -1 and move it to be the power of 16, of base 16. So we do know that 16 to the -1 is really what? 1 over 16. So what I really have is log base 3 of 1 over 16. And on the other one, I want to move this 1/3 up. And that's really the third root of 64. And the third root of 64 is 4. 4 times 4 times 4 is 64. So I really have plus log base 3 of 4. And now that we have the same log base 3, we could condense it with the product property and put them as this guy and this guy, put them as one single log base 3 of, but I need to multiply 1/16 times 4, which becomes 4/16, which reduces down to 1/4. So that's your final answer on number 10, log base 3 of 1/4. Let me give you a little different angle. Yeah? Check this out. Let's say I did move this 1/3 up, and we know, and if we don't know, use the calculator, 64 to the 1/3, it gives you 4. So what we really have is negative log base 3 of 16 plus log base 3 of 4. So another option, there's many roads to the same place. Another option would be to take this one and switch them. Right? 2 plus 3 is the same thing as 3 plus 2. It's called commutative property when you're adding things together. So if we have a negative number added with this positive, we could just switch them and put the -1 second. So what would that do? That would simply make it look like this. Log base 3 of 4 minus log base 3 of 16. And then that would let me apply what property? Quotient property, exactly right. So if I did the quotient property, it'd be log base 3 of this first one divided by the second one, 14 or 4 over 16. That also reduces down to the final answer that we got previously, log base 3 of 1/4 as well. So different ways of doing it. Anyhow, let's move on to the actual practice for today. Go ahead and pick any question on this front side. Which one? 11? Why not? 11. What property are we going to use to condense? The product. So we're going to take this log base 6 and that log base 6, we're going to put it together as one single log base 6, but it's of this guy times this guy. So x times 9 is simply 9x. And of course it's equal to log base 6 of 54. The reason why we condense these two logarithms is because you could only get rid of a logarithm if you only have one logarithm. That's when you could actually take the left side of the entire equation and raise it to become power of base 6. And what you do to one side, you do to the other side. And that's where these guys eliminate. And you end up with a nice, beautiful 9x equals 54. Divide by 9 on both sides, you'll get x equals 6. Ta-da! Too easy, right? Pick another one. Front side. 14. By the way, we're doing the even ones. I recommend doing all of them. 10 through 30 all, or 9 through 30 all. But at the very least, I want you to do the even ones. Number 14. What property am I going to apply on number 14? Product and also power, right? Which one do I do first? Well, this 4, I need to move it up here to the x so it doesn't get moved or placed anywhere else. So I'm going to put this 4 on the x using that power property. So I'm going to move it up. It's going to be an x to the 4th. If you want, you could just scratch it out, and there's your new problem right there. Log base 2 of x to the 4th plus log base 2 of 5. Now I'm going to condense with what property? Product property, which means that if I have log base 2 and log base 2 with that plus sign in between, I could condense it to one single log base 2 of x to the 4th times 5. So when I multiply x to the 4th times 5, what do I get? 5x to the 4th. It's actually kind of similar to the problems we already did. Equals, we do have log base 2 as well on this side. That's great. And we have 405. What do I do now to solve this problem? I need to get rid of those logs. What do I do? Raise them to become powers of base 2. That way they eliminate, and then the 5x to the 4th comes back down. The 405 comes down. Solve this like if it were any other equation. Divide by 5. Divide by 5. What is 405 divided by 5? X to the 4th equals 81. And now we need to get rid of that 4th power, so I'm going to apply a 4th root. A 4th root. So x will equal what times itself 4 times will give you 81. That is 3, right? Now it is a 4th root, and kind of like on a 4th root, kind of like on a square root, you have to put a plus or minus in front of your answer when you apply a 4th root, a 6th root, or even a square root. Any even root, you have to put a plus or minus. Now the question is, will both of those answers work, or are one of them extraneous? You have to take a moment and plug in 3 right there. The 3 works, but the negative 3 will not work. So please do not put a plus or minus on your answer, because the only answer that works is x equals positive 3, not the minus. Okay? Sometimes it will work where you get a negative 3, and when you plug it in, you have something like x plus 5, and it's negative 3 plus 5, which makes it positive 2, which is okay, but you cannot end up with a negative inside a logarithm. Which other one would you like to do? 12. What property am I going to use? Quotient. Log base 8 of something divided by something. What is that? 48 divided by w. What does that equal? Log base 8 of 4. How am I going to get rid of the logs? Raise them to become powers of base 8. Base 8. These eliminate. We have 48 divided by w equals 4. How do I get rid of that fraction that has a denominator of w? Multiply by w. Multiply by w. So we end up with 48 equals 4w. Divide both sides by 4. You're going to get 12 equals w. Any other ones? 16 is an even one. 15, if you look back on this video itself, you'll see how we simplified this one, remember? This was almost identical to it. 16, let's do 16 because we're doing the even ones for homework. So let's condense this side over here. This one's already simple, but But let's condense this to one single log base 2. We're first going to apply the power property. That 5 is going to go up here on the 2. Once you put it up there, you could just scratch it out. And what is 2 to the 5th really? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So for the sake of being neat, let's rewrite it. Log base 2 of 32 minus log base 2 of 8. So what am I going to apply next? What property will I apply next? Quotient. Log base 2 here, log base 2 there. Let's make it one single log base 2. And it's going to be of something divided by something. It's that 32 divided by 8. 32 divided by 8. Wait a minute. What is 32 divided by 8? Might as well just change that to a 4, huh? So you really have log base 2 of 4 equals log base 2 of d. We could actually do log base 2 of 4. You guys want to do that, or do you want to raise both sides to become powers of base 2 and both logs disappear? Okay. If I wanted to, I could change this to a 2, because 2 to what power gives you 4? 2 to the second power gives you 4. So this answer is actually 2. Either way, you're going to get the same answer. If you raise both sides to become powers of base 2 to eliminate these guys, what's your final answer going to be? D equals 4. Does anybody want to see any questions on the back side? Anyone? Which one? It's not like you're doing any work. Just ask me. I'll do it. 22. Fun stuff. What property could I use to condense? Quotient. All right. So the minus sign indicates I'm going to take this log base 4 and that log base 4 and put them together as a single log base 4. And I am going to divide this one by this one. So it's x squared minus 4 over x plus 2. Dang, you guys picked a winner. And it does equal log base 4 of 1. Log base 4 of 1. There's so many different roads that I could choose to go through right now, right? I could factor this and cancel. I could change this to a 0, because log base 4 of 1, if you do that on the calculator, it'll give you 0. 4 to the 0 power gives you 1. I could raise both sides to become power of base 4. There's so many different correct steps that I could do. So which one do you guys want to do? Raise them and get rid of the log base 4s? Sure, why not? So we put a 4 right there, 4 right there. This disappears, this disappears. Your equation becomes x squared minus 4 divided by x plus 2 equals 1. Let's multiply both sides by x plus 2. Again, you could go a different route. You could say, I want to change this to become x plus 2, x minus 2, and then cancel out the x plus 2s. But yeah, let's get rid of that fraction by multiplying by that denominator x plus 2. That way it completely cancels. What you do to one side, you do to the other. Multiply by x plus 2 over here. So your new problem becomes x squared minus 4 equals x plus 2. So what we have is a quadratic equation. And in order to solve a quadratic equation, you're going to have to set it equal to 0. So subtract x, subtract 2, subtract 2. And you're going to have, sorry about that, it's kind of ugly, but x squared minus x minus 6 equals 0. That's your quadratic equation. Yay? And now you could solve that quadratic equation that's set equal to 0 by using the quadratic formula. X equals negative b plus or minus square root of b squared minus 4c divided by 2a. Or you could factor, split, and solve. I prefer factoring, splitting, and solving, especially because there's no a value. So what times what is negative 6 that if you combine together is the middle value negative 1? Negative 3 and positive 2. And when you split them, you're going to get x minus 3 equals 0, x plus 2 equals 0, which means your two answers are x equals 3 and x equals negative 2. Your two possible answers, that is. Why do I say possible? Because you can't end up with a negative inside a logarithm. Now that does not make it automatic that this guy's wrong. You got to actually think about plugging it back in here. If I plug in a negative 2 in here and then square it, what's negative 2 squared? Positive 4. And then positive 4 minus 4, that's 0. Could we do log base 4 as 0? Actually, we can't, right? Try it on a calculator. Go log base 4 is 0. It'll probably say error. Because in a logarithm, you can't have negatives. You can't even have 0. Think about it. Whatever base you have, if I say 4 to what power gives you 0, it can't happen, right? There's no way 4 to any power will give you 0. 4 to a negative power will give you a fraction, not 0. 4 to the 0 gives you 1, not 0. So you can't have 0, you can't have any negatives. And if you tried it on a calculator, it would say error. So -2 can't work. Sometimes it will. The 3, will the 3 work? Let's see, plug in 3 right there. Yeah, I get a positive 5. 3 right there. 3 squared is 9. 9 take away 4 is 5. So this is my only answer, x equals 3. Any others? You guys good? Guys ready for a quiz on Friday on this? All right, let's practice.